Hi class, this is part 3 of section 5.1 on polynomial functions. So for example 7, we are now graphing polynomial functions, and we will continue this in the next section in 5.2. Okay, so for number 7, we are asked to list the real zeros of the function and also the multiplicity, determine whether the graph touches or crosses the x-axis at the corresponding x-intercept, determine the maximum number of turning points, and then also what is called the end behavior. Okay, so I like to put this information in table form. So the zeros of my function are 0 and -4. Okay, so 0 is a 0 because of this x squared right here. And then if x plus 4 is equal to 0, then our x would be -4. So that's how we get the two zeros. The multiplicity, if you remember, are the exponents. So the exponent for x is 2, and then the exponent here for the x plus 4 is just 1, since nothing is written. Okay, if you have an even multiplicity, the graph will touch the x-axis at that point, and if you have an odd multiplicity, the graph will cross. Okay, so there are zeros, multiplicity, touch and cross. Okay, and then down here the graph touches the x-axis at the corresponding x-intercept if the multiplicity is even. So to help remember this, maybe think of y equals x squared. That has an even multiplicity at 0, and the graph touches, whereas y equals x cubed has an odd multiplicity at 0, and our graph crosses. Okay, the degree of the function is 3. So remember, when we're multiplying, if the function is given to us in factored form, it makes it really easy to find the zeros. Okay, but for the degree, we have to kind of figure out what would happen if we multiplied it all out. So remember, if you multiply, add your exponents together. So 2 plus 1 is 3. The maximum number of turning points is always 1 less than the degree. So in this case, 2. All right, so for part C here, determine the maximum number of turning points. This will always be 1 less than the degree. Okay, and it doesn't mean that the graph turns exactly 2 times. It just means it turns at most 2 times. Okay, and then we also want the end behavior of the graph. So in MyMathLab, this is worded something like find the end behavior and determine what happens when the absolute value of x is large. Okay, so that just means what happens when x is large and positive, but also when x is large and negative. Okay, so basically our graph looks a lot like -x to the 3rd power. Okay, I don't want you to multiply this out, but just to show you the end behavior, I'm going to do it real quick. So we have -x cubed minus 4x squared. In this problem, it was easy to multiply it out, but if you have a lot of FOILing to do, it's not something that you want to have to do. Okay, so the end behavior, this is basically saying that anytime you have a polynomial function, the graph looks mainly like this first guy here, the power function, right? -x to the 3rd power. And the other stuff does affect the graph, but not when x is a huge number. So if x is 1,000,000, 1,000,000 cubed times -1 has a much bigger impact on the answer than 1,000,000 squared times 4. Okay, even though 1,000,000 squared is a big number, 1,000,000 cubed is so much bigger that it overpowers anything else. Okay, so that's why the graph looks like -x to the 3rd power. Okay, and then you have to know what this graph looks like. So -x to the 3rd power is up here in the 2nd quadrant, and then it ends in the 4th quadrant. Okay, so if you remember, I drew x cubed down here a second ago. That one's increasing, so the negative reflects it over the x-axis. Okay, and the end behavior tells us how to start graphing the function, so that's what we want to do next. So the fact that x cubed starts here in the 2nd quadrant, that tells me where to start my graph, and then I'll go through the zeros, and then I have to end down here in the 4th quadrant. Okay, so if I don't end up down here, then something went wrong. Okay, so this is just what I was talking about. And now we want to put it on the graph. Okay, so we need our x-intercepts. So we have 0, 0, and -4, 0. Okay, and remember, these are just going to be a sketch of the graph, okay? We start, because of the end behavior, we're starting up here in the second quadrant. I'm going to come down to the -4, and I cross. And then at some point, I don't know how far down I go, but obviously at some point I have to turn because I'm going back up to the origin, but then I just touch at the origin, meaning I come back down here and end up in the fourth quadrant. So that matches what I said the end behavior was going to be, because I knew to start here in the second quadrant and I was supposed to end up here in the fourth quadrant. If you forgot to touch at the origin and you crossed, you would have ended up in the first quadrant, and then you should have known something was wrong because you were supposed to end up in the fourth. Okay, good. So that's it on the graph. I only need points labeled along the x-axis. Okay, we don't know how far down the graph goes. We don't really know how steep it is either. Right, so based on our information, that blue graph is also, you know, based on the information we have, that one's fine as well. Okay, so just make sure that you're touching and crossing when you're supposed to be, and you start and end in the correct quadrant. So here it is graphed on Desmos. Desmos does not put any arrows, so you guys will need to do that. And again, you don't need any numbers along the y-axis. We know that the graph goes down, but we don't know how far it goes or anything like that. Okay, so let's do it again because these take practice. All right. Same direction, so we want the zeros, multiplicity, determine if the graph touches or crosses, maximum number of turning points, and the end behavior. Okay, so here's our table. The zeros are going to be 2, -2, and -4. Okay, from hopefully everyone sees where I'm getting these numbers. So looking at my factored form, the multiplicity of 2 is 2, and the multiplicity of -2 and -4 are each 1. Remember, if it's an even multiplicity, the graph touches. Odd multiplicity, the graph will cross. So we've done A and B. Maximum number of turning points. So remember, this is always 1 less than the degree. So let's figure out the degree of our function. We're multiplying here, right? So we add the exponents together to get the degree. So this is degree 4. And the graph looks a lot like y equals x to the 4th power. Okay, so that's actually the end behavior. Maximum number of turning points is going to be 3. Okay, good. And then again, the end behavior, your book words it somehow like the absolute value of x is large. What's happening with the function? Okay, so if x is large and if x is really, really big and positive or really, really big and negative, the graph looks like y equals x to the 4th power. Okay, so here's one of those times where you don't want to have to multiply it all out to figure that out. Okay, if we did multiply it all out, we would get something like y equals x to the 4th plus something x cubed plus something x squared plus I think we'd end up with 32 here at the end, right? We don't need all that information. We just need this first guy here, okay, that power function. So y equals x to the 4th, that is the end behavior. Okay, so remember the end behavior tells us where to start and stop the graph. So we need to know where to start because otherwise we don't know whether it's the second or the third quadrant. And then we should be ending in the first quadrant here, because this is basically what the graph of y equals x to the 4th looks like. Okay. So here's our graph. Put in the zeros. So -4, -2, and then also +2. The graph needs to start here in the second quadrant. When I get to -4, I'm going to cross, which means at some point I have to turn around because at -2, I'm also crossing. I come over to +2, and here I touch the graph, touch the x-axis, I mean, and then I end up in the first quadrant, which is good right? So we're happy about this. It matches where we said we would end up based on the end behavior. Okay, and that's as much of a sketch as I need. So you're just going through the x-intercepts, you're touching or crossing based on what you're supposed to be doing, what you have in your table. The end behavior tells you where to start the graph. So whether it's second quadrant or third quadrant, and also where should you be ending, first or fourth. And in this case, we wanted to end up in the first quadrant, and we did. Okay, so just a reminder, touch anytime it's even, cross anytime the multiplicity is odd. We said we have a 4th degree polynomial, which means it turns at most 3 times, and it looks like x to the 4th. And then here's it graphed on Desmos. So again, we just need the arrows. If we look here at the turning points, the graph turns once here, a second time here, and a third time here. That tells you not to try to make the graph more fancy, right? You're coming up here, don't give it an extra squiggle and keep going. Now the graph turns 1, 2, 3, 4, 5 times, and it can't do that, okay? So knowing the number of turning points, even if you're under it, you don't know where that extra turning point would be. So just put in turning points where you know they have to be. Okay, good. All right, so here's one I'd like you to complete and turn in through Desmos. So, sorry, turn in through Canvas. So list the zeros in the multiplicity. I like it in table form, but if you prefer it some other way, that's okay too. I just want to clearly see the zeros, the multiplicity, and then whether the graph should touch or cross. Tell me, you'll have to figure out the degree of the polynomial, because that's how you determine the end behavior of the graph and also the maximum number of turning points. It doesn't say here to sketch it, but I do want you to do I'll put it in, a quick sketch of the graph like we've been doing. Okay, I don't need anything on the y-axis, only the x-intercepts on the x-axis. Okay, good luck. All right, and then we do have one more example to do. Okay, so find the polynomial function that might have this given graph. Okay, so again, we're kind of doing it backwards than what we normally do. So let's, 2, 3, I'm gonna, each tick mark is 1 unit. So this is +3, -1, and -4. Okay, so basically we know the zeros of the function. And I also know whether the graph touches or crosses. Okay, so -4 is a 0, so x plus 4 must be a factor. -1 is a 0, so x plus 1 must be a factor. 3 is a 0, so x minus 3 is a factor. Notice that the graph is touching here at 3, which means it has an even multiplicity. You could pick 2 or 4 or 6. I'll just do 2. Also here at -4 and -1, the graph is crossing, so it must have an odd multiplicity. If you want to write a 3 or a 5, you can. Okay, it actually is just 1. If you zoomed in on the graph, it looks linear here. If we just zoomed in on that one area, if it was quantity cubed, when you zoomed in, it would look more like our cubic function. Okay, but I'm just checking whether it's even or odd. So 1, 3, 5, any of those are good. Okay, let's see. Check the degree here. So right now this is degree 4. So we're good to go. I could put any number here that I want as long as it's positive. So I could put a 2 here or a 4, a 5. Okay, just make sure it's positive because the graph is opening up. Right, so a negative would have reflected it about the x-axis, and so that's not happening on the graph. Okay, so any coefficient, any positive coefficient out here is fine. Okay, so there's the graph, and I just left it as a 1 out front. Okay, that's it. So work on those problems. It does take practice, but we'll be doing more graphing in the next section as well. Okay, good luck. Let me know if you have any questions.